In the middle of the last century, something happened in physics that shook even the toughest, most skeptical scientists. Experiments began to show that two particles, separated by kilometers, even by oceans, could still behave as if they were one. Measure one, and instantly, the other knows. No signal traveling, no hidden wire, no physical bridge. Just an eerie, silent coordination that Albert Einstein once mocked as spooky action at a distance. But here's the twist. Decades later, we confirmed it. Not a theory, not philosophy, a fact of nature. Quantum entanglement is real. Now here's where it gets uncomfortable. If nature allows for this invisible connection between particles, what does that say about us? About consciousness, about the human experience, about the strange sense that your thoughts, your emotions, your very being might ripple beyond your body. Could physics be hinting at something people have whispered for centuries, that we are all somehow linked? The idea sounds spiritual, mystical even, and for a long time scientists ran from it. But the deeper we've gone into quantum theory, the harder it has become to keep the worlds of physics and philosophy apart. When you break reality down to its smallest scales, it refuses to stay locked in the tidy categories we built. It dissolves boundaries. So here's the question that will guide everything that follows. Is entanglement just a strange laboratory trick? Or is it the first scientific proof that connection is the fabric of existence itself? At its core, quantum entanglement begins with something deceptively simple, a pair of particles created together. Imagine two photons born from the same spark of energy. From that moment, they carry a kind of shared fingerprint. No matter how far apart they drift, this hidden link remains. When scientists measure one photon's property, say its polarization, the result isn't random noise. The other photon instantly adapts, showing a perfectly correlated result. What makes this so radical is not just the synchronization, but the timing. The coordination seems faster than light. According to Einstein's relativity, no information can travel quicker than light through space. Yet, entanglement acts as if distance doesn't matter at all. Physicists have tried to explain it away with clever loopholes. Maybe the particles carried a hidden script from the start. Maybe we just weren't looking closely enough. But in 2015, a landmark series of loophole-free experiments closed the escape routes. The verdict: entanglement is real, and it cannot be explained by hidden instructions or classical physics. So what's really going on? Here's the radical possibility. The particles aren't two separate things exchanging messages. They are one system, smeared across space. In other words, separation is an illusion. What we call two photons is really one quantum state, stretched out. The act of measurement doesn't send a signal across the universe. It collapses the entire shared state in a single stroke. That's where the metaphysical door cracks open. If separation is not fundamental for particles, why should it be for us? Our brains, our bodies, our thoughts, they're built from these same quantum ingredients. Could it be that the sense of being an isolated individual is just as much an illusion as thinking those photons are independent? Of course, many physicists warn against leaping too far. Entanglement is subtle, and it doesn't mean telepathy or instant communication in the way science fiction imagines. But still, the raw fact is unsettling. Reality has non-local threads that bind what should be separate. And here comes the cliffhanger. If entanglement reveals that particles are not truly separate, then we have to ask, is the entire universe entangled? Are you right now linked to every star, every stranger, every living thing in a way so deep that science has only begun to scratch the surface? Everyday life tricks us into believing in sharp boundaries. You see your body in the mirror, and it feels obvious. This is you, and everything else is out there. You walk into a room, and you don't merge with the furniture. You talk to a friend, and you feel like two distinct beings trading words across a gap. Common sense screams separation, but quantum physics whispers something far stranger. That gap might not be as real as it seems. Think about sound for a moment. When you hear someone's voice, it feels like it exists inside your head. But in truth, the sound is vibrations in the air, traveling waves that reach your eardrum. The sensation of a voice inside is an interpretation, not the raw reality. Entanglement suggests that separation itself might be another interpretation. Here's the illusion. We assume the world is made of individual objects stacked side by side. But experiments reveal that what looks like two can behave as one. Two electrons in different labs aren't two, they're a shared system. Two photons shot in opposite directions aren't two, they're a unity stretching across space. If particles refuse to honor boundaries, then maybe boundaries are not written into the code of the universe. And if you zoom out, this illusion breaking gets even stranger. Your body is exchanging particles with the environment all the time. Every breath you take replaces molecules, every sip of water becomes part of your cells. Physically, you are in constant entanglement with the world, even without invoking quantum mechanics. Add quantum theory on top, and the very idea of being a self-contained unit collapses even further. That doesn't mean individuality is fake. It means individuality is a perspective, not the foundation. Like a photograph of an ocean wave, beautiful, distinct, but only meaningful as part of the sea. Here's the shock. The separateness you feel right now may be the most persistent illusion of all. The deeper we probe the quantum world, the more we find unity hiding under difference. And this leads to a profound tension. Science tells us we are linked at the deepest level, yet society, culture, even language reinforce the myth of absolute isolation. So the question becomes, which do we trust? The story common sense tells us, or the story nature itself is revealing? Because if the quantum view is right, then the walls we live behind, me here, you there, the universe beyond, may not exist the way we think they do. Evidence in science isn't built on belief, it's built on layers. And the story of entanglement is a perfect example of how each layer stripped away doubt until we had no choice but to face the impossible. Let's climb that ladder. Step 1. The equations. In the 1920s and 30s, Schrödinger and Dirac discovered that the mathematics of quantum mechanics naturally allows for states that are not independent, but shared. Schrödinger even coined the term Verschränkung, or entanglement, to describe this inseparable linking of particles. On paper, it looked bizarre, but it was a direct outcome of the math, not an add-on. Step 2. Einstein's challenge. Einstein, Podolsky, and Rosen published their famous paper in 1935, arguing that entanglement proved quantum mechanics was incomplete. They thought hidden variables, unseen instructions buried in particles, could explain the weirdness. This was their way of rescuing reality from what Einstein called spooky action at a distance. The challenge was sharp. Prove us wrong. Step 3. Bell's theorem. In 1964, physicist John Bell gave the world a tool to test Einstein's idea. He showed that if particles had hidden instructions, their correlations would follow strict mathematical limits. But if entanglement was real, those limits could be violated. This was no longer philosophy. It was a recipe for an experiment. Step 4. The experiments. Starting in the 1970s and accelerating through the 80s and beyond, physicists ran Bell tests with entangled photons. Again and again, the results broke Einstein's limits. Hidden variables couldn't explain it. By 2015, 3 separate teams achieved loophole-free experiments, eliminating every technical excuse skeptics could point to. The conclusion was overwhelming. Entanglement is not a trick. It is woven into reality. And the ladder doesn't stop there. In 2022, the Nobel Prize in Physics was awarded to Alain Aspect, John Clauser, and Anton Zeilinger for their pioneering experiments with entangled photons. The highest scientific recognition now celebrates what Einstein doubted. What began as spooky is now honored as fundamental. But here's the part that still unsettles. Experiments prove entanglement exists, but they don't explain why. The math works. The tests agree. The Nobel says yes. Yet the mechanism, the deep truth of how the universe knits together what seems separate, remains a mystery. So here's the cliffhanger. If entanglement is not just real, but universal, then what else might be entangled that we've never dared to test? Could consciousness itself, the very thing you're using right now to listen, be part of that invisible web? When science confirms something as radical as entanglement, the ripples don't stop at physics labs. They leak into philosophy, psychology, and even spirituality. Why? Because for millennia, countless traditions have whispered the same idea, that all things are one, that separation is an illusion. Quantum mechanics, unintentionally, seems to echo that ancient intuition. But here's the catch. Scientists are cautious, very cautious. They warn us not to confuse metaphor with mechanism. Just because particles are entangled doesn't mean people are literally linked mind to mind in the way mystics describe. Critics argue that using quantum theory to justify spirituality is dangerous, a leap too far. They call it quantum mysticism, a slippery slope where rigorous physics dissolves into wishful thinking. And yet, the parallels are hard to ignore. When experiments show two particles acting as one across vast distances, it resonates with the intuition that consciousness, too, might not be locked in the skull. That maybe awareness, meaning, and connection are not isolated sparks, but expressions of something deeper and unified. Here's where the shockwave hits. Entanglement forces us to ask whether reality is fundamentally relational rather than individual. Maybe the universe isn't made of separate objects, but of connections themselves. You aren't just a person in a world. You are a node in a cosmic network. This shift is not just poetic. It rewrites how we think about meaning, ethics, even identity. Imagine what it does to concepts like empathy. If separation is partly illusion, then compassion stops being optional. Caring for another isn't just morality, it's physics. Likewise, isolation becomes suspect. Loneliness may be real emotionally, but ontologically, the science says, you are never truly alone. Still, the scientific community draws boundaries. Physicists insist that while entanglement is real, it cannot be used to send messages faster than light, nor does it provide direct evidence that human consciousness is entangled. To them, stretching the phenomenon into metaphysics risks distorting the science. But here's the irony. Science itself admits it doesn't know what entanglement means. The math works, the experiments prove it, the Nobel Prizes celebrate it, but the interpretation? Wide open. So if the universe itself refuses to give us clean boundaries, why should we expect philosophy to play by old rules? And this leads us to a daring frontier. If entanglement shakes the foundation of what it means to be separate, what happens when technology begins to harness it? Not just in labs, but in ways that could alter human society itself. The laboratory proof of entanglement is only the beginning. Once humanity learns to control it, we enter entirely new territory. And the first glimpse of this future is already here: quantum communication. Unlike classical signals, entangled particles can be used to detect any attempt at interception. China has already launched satellites that use entanglement to create ultra-secure communication channels between continents. A global quantum internet is no longer science fiction. It's a roadmap. Next comes quantum computing. Entanglement is one of the key ingredients that gives quantum computers their extraordinary power. While a classical computer flips bits, 0 or 1, quantum bits can be entangled, creating vast webs of correlations that allow calculations impossible for ordinary machines. This isn't just faster computing, it's a new kind of intelligence. Imagine designing drugs, cracking codes, or simulating entire ecosystems at a level so detailed our current computers collapse under the weight. Entanglement is the silent engine making that leap possible, but the horizon stretches further. Some researchers are exploring quantum networks of sensors, devices that use entanglement to measure the world with unprecedented precision. Imagine earthquake detection before tremors even begin, or medical imaging that maps the body at resolutions no MRI could dream of. The future of science itself could be rewritten. And then, there's the big, unsettling question: what happens when we begin to scale this? If small systems can be entangled, why not larger ones? Already, experiments have entangled massive molecules, far beyond single photons or electrons. Step by step, the boundary between quantum weirdness and everyday matter erodes, which raises a chilling possibility. Could systems as complex as the brain show quantum entanglement at meaningful scales? If so, consciousness might not be a local process at all. Now picture where that leads. A future where thought, identity, or even memory could be linked through entanglement. Not telepathy in the cartoon sense, but a deeper form of connection, direct, instant, immune to distance. Societies built not on individual isolation, but on a kind of quantum web of shared awareness. Utopian? Maybe. Terrifying? Definitely. But the seeds are already in the physics, and here comes the cliffhanger. If technology keeps pushing the limits of entanglement, then the boundary between science and spirituality may vanish altogether. Not because of mysticism, but because physics itself will force us to confront a truth we've resisted. What if the future of humanity is not individuality, but entangled existence? All of this might sound cosmic, abstract, almost untouchable. Satellites, Nobel Prizes, quantum computers, fascinating, yes, but far from the pulse of your daily life. But let's bring it closer. Let's talk about you. Every time you feel connected to someone, a friend finishing your sentence, a loved one sensing your mood without a word, you chalk it up to psychology, to familiarity. But what if that resonance, that invisible bond, is not only metaphorical? Entanglement reminds us that the deepest truth of reality is connection, that the feeling of being woven into the lives of others isn't just poetry, but an echo of the universe's fabric. Think about how often life teaches you the opposite. Workplaces that treat people as replaceable, cities where neighbors barely know each other, social media that promises connection but often delivers isolation. Against that backdrop, the quantum world whispers a rebellion. You were never separate to begin with. The very atoms in your body carry histories of stars, oceans, forests. The particles composing you right now could be entangled with others light years away. And if you internalize this, even just for a moment, everything shifts. Relationships stop being transactions and start being revelations. Empathy stops being an effort and starts being recognition. When you see another, you are glimpsing a reflection of the same web you belong to. This doesn't mean surrendering individuality. You're still you, with your own memories, your own story. But individuality is no longer the prison it once seemed. It's a perspective within a larger whole, like one melody inside a symphony. You are both unique and inseparable. Here's the challenge. Can you live as if this is true? Can you walk into a crowded street and feel, not distance, but kinship? Can you meet conflict and see, behind the clash, the shared entanglement that makes enemies and allies part of the same fabric? Of course, science won't hand us easy instructions. Entanglement doesn't give you a recipe for happiness or a shortcut to peace, but it gives you something subtler, a reason to believe that your sense of connection is not just wishful thinking. It is written in the language of physics itself. And maybe, just maybe, embracing that truth could change the way you carry yourself through the world. Because the next time you feel alone, you might remember, even the smallest particles refuse to be separate. Picture yourself standing on a beach at night. The horizon stretches endlessly, waves rolling in from a distance you cannot see. Above you, the stars burn silently, each one a furnace light years away. And yet, in this moment, you are not separate from any of it. The salt air you breathe was once part of ancient oceans. The iron in your blood was forged in stars long before Earth existed. The photons from distant suns are striking your eyes right now, weaving their journey into your consciousness. That beach scene is not poetry. It's physics. It's entanglement in disguise. The universe does not divide cleanly between here and there. It refuses to let separation have the final word. And whether you're thinking about subatomic particles or the stars overhead, the truth is the same. Connection is the rule, not the exception. So when you leave this video and return to your routines, conversations, work, moments of doubt, moments of joy, carry this question with you. What if every choice, every gesture, every thought ripples into a web wider than you can imagine? What if your life is not just yours, but part of something profoundly interconnected? This is what entanglement dares us to consider. That being human isn't about being alone in a body, but about being a strand in the greatest network the cosmos has ever woven. Now I'll leave you with this. Do you believe quantum physics is proving that we are all connected? Or is this leap still too mystical for science? Tell me below. Your view might change someone's mind.